Hello, I'm Jose with SSA Architecture, small studio associates, licensed architects in Las Vegas, Nevada, and the surrounding area, including California and Arizona. A large part of planning a new architectural project is that of planning how the building will deal with emergencies, which in many cases is that of a fire. The first step is creating an exiting plan. It is important to make it easy on the people within the building to escape in case of a fire. With people out of the building, it then becomes important to try to keep the fire from spreading and causing more damage than it already has. The building itself should be already capable of slowing the spread of a fire, as exterior walls and walls that divide the building into different spaces should be fire-rated walls. Typically, a 1-hour rating is the lowest allowed for demising in exterior walls. This is not the only way to prevent the spread of a fire, however, as it is common to find fire sprinkler systems in commercial spaces. Though fire sprinklers aren't always required in a given commercial space, it has become the standard for most commercial buildings to have a working, custom-designed fire sprinkler system. These systems are regulated by the local authority in a process typically starting with a fire plan review and ending with the final fire inspection. While analyzing the proposed fire suppression system, these reviewers and inspectors usually base their evaluation on the International Fire Code, the NFPA 13 standard for installation of sprinkler systems, and other applicable fire code books. We will look into how the code requirements can help designers determine stuff like whether there is a need for a fire sprinkler system, what rooms in the building can be permitted to omit the use of fire sprinklers, which occupancy hazard group this building is classified as, what sprinkler heads to use, and how to design a fire riser room. Automatic sprinkler systems are oftentimes necessary to protect the building from burning down and to save the lives of the building occupants. In order for a sprinkler system to achieve these goals, designers have to assess the potential of ignition in each space. According to NFPA 13, all newly constructed commercial buildings that are 5,000 square feet or larger are required to have sprinkler systems. However, sprinkler systems can be omitted in spaces that are unlikely to ignite or if the sprinkler installation may not be practical based on the building geometry. This typically applies for concealed spaces that aren't built out of combustible materials. Concealed spaces in commercial buildings larger than 5,000 square feet should be sprinklered unless the local authority allows them to be omitted. Buildings or parts of buildings are assessed for potential of ignition based on their occupancy hazard classification. NFPA 13 categorizes buildings or parts of buildings into these 6 occupancy hazard classifications. 1. Light hazard, 2. Ordinary hazard group 1, 3. Ordinary hazard group 2, 4. Extra hazard group 1, 5. Extra hazard group 2, 6. Special occupancy hazard. These 6 classifications are based on the quantity and combustibility of the contents, the expected rates of heat release, the total potential for energy release, the heights of stockpiles, and the presence of flammable and combustible liquids. Once the building occupancy has been established, the category it falls under will determine the sprinkler spacing and coverage area per sprinkler. In turn, this helps determine how many sprinklers are needed and what the required water flow pressure is. After using the formulas from NFPA 13 to calculate the required water pressure for each sprinkler, the next step in the process is to find the right sprinkler heads for the building. When choosing sprinkler heads, it is important to consider the max gallon per minute and the max pressure rating required of the sprinklers. The piping material, the sealing finish material, and the aesthetic properties of these sprinklers are considerations. In some situations, it might be important for the sprinkler heads to be concealed from view, in which case there are sprinkler heads with metal cover plates or white caps that function just as any other sprinkler head without being visible to the building occupants. The last design consideration I will cover for this video involves the use of fire riser rooms. There are a lot of complicated rules for designing a fire riser room. This is because of its importance when it comes to a life safety situation. The main concerns for designing a fire riser room are the signage, the location of the room, the accessibility to the room, and the compliance with the clearance requirements. Fire riser rooms need to have signage to help locate the room and some of the components of the fire riser unit. They should be located along the exterior wall, usually with an exterior door so that workers and emergency personnel don't have to enter the building to access the fire riser room. There are also clearance requirements meant to allow enough space for the workers to safely remove some of the larger components such as control valves and alarm check valves. A common fire code infraction is that of cluttering of fire sprinkler rooms. The room is not a storage room. Extra items in the room are not permitted because they can slow someone down while accessing valves during an emergency. The 2018 edition of the International Fire Code requires 36-inch clearance around the risers for proper access. These are just some of the requirements for designing a high-quality fire suppression system. These requirements are all based on the applicable fire code books. After the local authority approves a set of fire suppression plans, the contractor can start installing his fire sprinkler system. This begins with the contractor tying the new piping with water supply lines. After this, installers can start to hang pipes from the ceiling, positioning them to terminate right where the plan locates the new fire sprinklers. Once the ceiling grid is installed, if all pipe terminations are located where they are supposed to be, the installers can connect specified sprinklers to each of the pipe terminations. Finally, the sprinklers and all the components of the incorporated fire suppression system must pass a final fire inspection. The final fire inspection is required for a building owner to receive their certificate of occupancy. That completes my video explaining the design process for a fire suppression system. If you have any questions, feel free to call us at 702-873-1718. Don't forget to like, favorite, and subscribe. You can also visit our website for information about us or to maybe get some answers on our frequently asked questions page. Visit smallstudioassociates.com.